The strange interstellar visitor, Oumuamua, that once whisked through our planet is back again, moving at an unprecedented speed towards the Earth. This time, even the scientists are terrified and sending warnings that Oumuamua will crash in about 2 weeks and nothing can stop it. Are we facing a potential disaster? Is this going to be the end of our planet? Join us as we dive into the urgent warning of this strange visitor that is about to crash. Chapter 1. The Discovery of Oumuamua. In 1837, an unknown object reached a notable cosmic milestone unnoticed by anyone. It crossed a distance of 1,000 astronomical units away from the Sun. For more than 100 years, this object kept advancing towards the Earth. Ironically, no scientists discovered it. It kept moving until October 19, 2017, when a scientist, Robert Workey, in Hawaii discovered it. An image captured by an astronomical telescope at the University of Hawaii revealed a faint, thin streak traversing the sky at a consistent pace each day. This day marked a historical event as it was the first recorded interstellar visitor. The discoverer thought of the best name for the creature and decided to call it Oumuamua, meaning a messenger from afar. Even though the discovery was made in Hawaii, it sparked a global initiative to observe the object through telescopes. It also caught the interest of astronomers from the SEI Institute, who eagerly engaged in observing the object. They also pushed the search further, hoping to find any extraterrestrial signs. You know, this object might just feature some advanced technology. What does Oumuamua look like, you may ask? Some describe it as a reddish, cigar-shaped rock object. Its elongated shape is almost 4 miles wide and about 10 times longer than it is wide. Thus, this description surpasses any asteroid or comet in our solar system. However, some still suggested that Oumuamua was either an asteroid or a comet. An asteroid is a small, rocky body orbiting the Sun, while comets are large objects made of dust and ice orbiting the Sun. Oumuamua was traveling at a speed of 196,000 miles per hour. This means it is more than 100 times faster than a bullet. This shocking revelation again sets it apart from what we can identify in our solar system. Whether it is an asteroid or a comet, let's try to distinguish between the two phenomena. Comets are composed of ice, while asteroids are rocks. Scientists first thought Oumuamua was a comet, but later changed their minds and called it an asteroid when it zipped past the Sun. But then, they still considered it an asteroid until measurements indicated a slight acceleration, which means it might be a comet. However, there's a clause to this again. The object accelerated much more than they predicted. This situation puzzled the scientists, leaving the question of what Oumuamua was hanging. A remarkable characteristic of Oumuamua was its periodic brightening and dimming every 7.3 hours. This dynamic sign indicated its rotation around its short axis. Such a pattern suggests that it might not be a comet. It suggested a more rigid and durable composition than the typically fragile snow-like material of most comets. It appeared dark red, similar to when moons in the outer solar system are affected by space radiation. Hold on a second. Could Oumuamua be an alien or Russian spacecraft? We all know the Russians are capable of anything on Earth. They always compete with the US. Besides, Oumuamua's color involves iron, as suggested by Dr. Mech, an astronomer at the University of Hawaii Institute. So what do they find out about Oumuamua? And has any satellite been able to track it down and predict where exactly it will crash? Chapter 2. Theories around Oumuamua. Various theories emerged to explain Oumuamua's identity. First, some believed it was a rock. Others proposed that it was filled with gas. But then, some experts astonishingly said that Oumuamua must be an alien aircraft. This raises the question of whether an alien ship is somewhere hiding while releasing a part of it to explore the Earth. But is that the truth? Let's dive deeper into the theories to find out more. According to Dr. Mech, Oumuamua must have been flung from a distant star following a supernova explosion. According to Elon Musk, it was formed when two objects collided and fused together. Astronomers were initially happy when they discovered that Oumuamua seemed to point toward Vega, the brightest star in the Lyra constellation. This star was known to possess a debris disk. By calculations, this object might have traveled to the present location in roughly 600,000 years. But then, the possibility of it coming from Vega didn't hold much water. That's because significant changes were noted in its path. Astronomers believed that Oumuamua must have encountered a new star system for the first time, considering its motion around the Sun. This was similar to the speed of nearby stars. Nonetheless, there's a possibility that Oumuamua must have been around the galaxy for billions of years. Another theory worth noting suggests that Oumuamua is a chunk of nitrogen ice. According to researchers Alan Jackson and Stephen Desch from Arizona State University, Oumuamua might just be a fragment blown off a Pluto-like object by a massive impact. However, to merge with this theory, Oumuamua would have to be smaller than initially thought. Another theory proposes that cosmic rays interact with surface ice in interstellar space, freeing hydrogen gas trapped in water molecules. This created a supply of hydrogen gas trapped in amorphous water ice. This is the theory from Daryl Seligman from Cornell University and Jennifer Bergner from Berkeley University. They suggested that Oumuamua gained warmth from the sun, which altered the structure of the ice and pushed it forward. Well, this may be true only if it was truly an ice. But that's not all. Astronomers Avi Loeb and Shmuel Bialy from Harvard University suggested that Oumuamua could be a solar-powered spacecraft. That sounds interesting. According to them, the various characteristics of Oumuamua suggest that it has an artificial origin, hinting at the possibility of extraterrestrial origin at play. This lends credence to the assumption that Oumuamua might be from an alien. No doubt, the appearance of Oumuamua lends credence to the fact that it originated from a place outside our understanding of the solar system. However, we can't draw a final conclusion because its true size and shape remain a mystery, and no device has been able to capture the actual image of this object. Astronomers only rely on its brightness and their knowledge of how asteroids and comets reflect light to guess the size. However, since no tail or coma had been found on the object, the comet theory was not approved. The comet theory also suggests that Oumuamua's apparent movement could be from the force that broke it free from a supposed parent object. However, repeated non-gravitational acceleration contradicts this assumption. In place of that, scientists coined a theory involving sunlight. If Oumuamua is extremely thin, around 0.3 to 0.9 millimeters, its movement could be due to solar radiation pressure. They proposed that Oumuamua could be a light sail, a technology demonstrated in space missions like the Japanese probe and NASA's NanoSail D2. These light sails use photons' kinetic energy to propel themselves through space. Therefore, they suggest that Oumuamua could endure a long journey through interstellar space through a light sail. They estimated it could travel at least 16,000 light-years from its home system, wherever possible. Additionally, Oumuamua's motion closely aligns with a region of the Milky Way galaxy called the local standard of rest, making it difficult to establish its origin. Well, we can't draw a final note on this just yet. So the question still lingers: what is Oumuamua, and who are those controlling it? Where is its final destination? The last time it was seen, it was on its way out of our solar system. Now we are being told it's about to crash. Where? On our planet. But before we dive further into that, scientists tried to understand Oumuamua's trajectory. What they discussed and tried to do is worth noting, as this will explain why they assumed that Oumuamua would crash in 2 weeks. So, let's get right into that. Chapter 3. Oumuamua's Trajectory. Scientists felt that they should send robotic probes with sails hurtling toward Oumuamua. However, this suggestion isn't possible now. And that's because the world has not produced an aircraft that could take up such a mission. Well, maybe sometime in the future, as projects like Breakthrough Starshot are already building on this. Whether scientists reach Oumuamua or not, its visit can prepare the world for future encounters. Even though Oumuamua had taken billions of years to arrive at its current location, it's just a fleeting moment on the cosmic scale. The Milky Way galaxy boasts an age of 10 billion years. Therefore, Oumuamua could have journeyed through approximately 20,000 star systems. Well, this is just a modest fraction compared to the galaxy's 200 billion stars. However, it's a good number of cosmic encounters for Oumuamua. It would have raised dust and debris, allowing the stars to intermingle. Therefore, Elon Musk and other astronomers believe that Oumuamua is on a fast race to the Earth. They had even predicted that it would enter the Kuiper Belt this year. Notwithstanding, no one has located Oumuamua. They only work on the information they can gather to determine its movement and possible arrival on Earth. But there's more to say about Oumuamua's trajectory, which scientists termed unconventional. They observed a notable non-gravitational acceleration, indicating that forces beyond gravity propel its motion. Dr. Mech explained that several factors could lead to this acceleration. She then proposed 6 potential causes. The first observation was that comets outgas. This is a common occurrence in comets. Outgassing occurs when a comet approaches the sun, and its surface ice sublimates, turning directly from solid to gas. This process gives the comet an additional push, altering its speed and rotation. Aside from the gravitational influence, the change in motion resembles the behavior of Oumuamua, aligning with the power observed in comets. As gas exits, a comet carries surface dust with it. However, Dr. Mech asserted that even if the comet lacked microscopic material, the potential presence of substantial dust on its surface might affect its speed. This consideration kept the idea of it being a comet alive, though only in terms of movement. Additionally, scientists observed viable wavelengths, which make it challenging to detect significant dust particles. Therefore, no visible evidence of dust leaving Oumuamua was observed. The absence of gas-related signs was also puzzling. Meanwhile, scientists and astronomers expected a significant amount of gas emotion to influence Oumuamua's speed. Unfortunately, all their efforts proved abortive. As far as they could search, no CN gas was detected. Considering that comets in our solar system can hold a significant amount of water, the strong upper limit set by the absence of CN has indicated that Oumuamua was chemically exceptional, and that's if it was a comet at all. Astronomers utilized the Spitzer Space Telescope to observe Oumuamua for over 30 hours, attempting to detect its thermal characteristics. However, they encountered challenges in their endeavors. Dr. Mech said that the observation, a thermal infrared test, detected heat emissions. In this case, their observation didn't yield any noticeable result. Interestingly, this fact can be detected even without any test. They concluded that Oumuamua might be brighter than anticipated if it exhibits thermal behaviors similar to a comet. An object's reflectivity, or how much light it reflects, can reveal details about its size, composition, and shape. Despite all these theories and propositions, no one has been able to unravel the mysterious identity of this interstellar object. So, what other thing do they discover about Oumuamua? Is it perhaps above what we anticipate and thus a great threat to the Earth in 2 weeks? Chapter 4. Beyond Your Imagination. First thought to be an asteroid, then later a comet, and even considered a possible alien spaceship by some, a duo of American astronomers now think they have solved one of the space rock's lingering mysteries. Observations made within the short period of its visit soon proved that Oumuamua was on what astronomers call a hyperbolic orbit, a boomerang-shaped trajectory that indicated the rock was not native to our solar system, but was only passing through the sun's neighborhood and would never be seen again. But is this observation complete? Would Oumuamua never be seen again? An interesting phenomenon around Oumuamua is its speed, which seemed to increase as the rock rounded the sun. Large bodies, such as planets and stars, can give smaller objects, including comets and asteroids, a gravitational kick that speeds them up. But in the case of Oumuamua, which at 54 miles per second, 87 kilometers per second, cruised 3 times faster than an average solar system comet, these gravitational kicks couldn't explain the observed acceleration. If you remember, this is one of the theories that seem a hard nut to crack for scientists. This acceleration swayed many scientists to conclude that Oumuamua must be a comet rather than an asteroid. Comets in the solar system receive additional momentum from the water and dust that evaporate from their icy nuclei as they warm up close to the sun. These comets, however, are famous for their spectacular tails that light up due to the outgassing process, and Oumuamua showed no signs of a tail. Many scientists have tried to explain the mechanism behind Oumuamua's acceleration, but all of the proposed ideas have had significant gaps. In a new study, Jennifer Bergner, an assistant professor of chemistry at the University of California, Berkeley, and Daryl Seligman, a U.S. National Science Foundation postdoctoral fellow at Cornell University, propose a new theory that they think might finally put the issue to rest. She has been trying to explain outgassing for several years. First, she thought the dust in the outgassing wasn't enough. Later, she thought it was made of some more volatile material than what they'd discovered in comets, such as hydrogen, nitrogen, and carbon monoxide. However, these explanations are subject to theoretical issues. Seligman said hydrogen, for example, would require extremely cold temperatures to freeze into objects the size of Oumuamua, and scientists don't expect such temperatures inside the dense molecular clouds where these objects form. He added that nitrogen is not ubiquitous enough in the Milky Way to account for the expected number of such bodies in the galaxy. Seligman and Bergner now propose that there might be nothing extraordinary about Oumuamua's chemistry. Instead, the object was subject to processes outside the solar system that astronomers don't know about from our observations of domestic comets. A comet traveling through the interstellar medium is basically getting cooked by cosmic radiation, forming hydrogen as a result, Bergner said. Our thought was, if this was happening, could you actually trap it in the body so that when it entered the solar system and it was warmed up, it would outgas that hydrogen? The team's calculations showed that, theoretically, the force of this outgassing hydrogen could explain the strange acceleration of Oumuamua. The astronomers even found more than 40 years of experimental studies demonstrating that high-energy particles, such as those present in cosmic rays, can split molecular hydrogen from water ice but keep it trapped inside an ice block. What's beautiful about Jenny's idea is that it's exactly what should happen to interstellar comets, Seligman said. We had all these stupid ideas, like hydrogen icebergs and other crazy things, and it's just the most generic explanation. Some scientists, however, are not satisfied with this explanation. Harvard University's astrophysics professor Avi Loeb, in his response to Seligman's and Bergner's study, claimed that the two miscalculated the surface temperature of Oumuamua, resulting in an incorrect estimate of the available amount of hydrogen in the iceberg. Loeb, who had previously suggested that Oumuamua may be an alien spaceship, thinks that the outgassing of the available hydrogen could not have produced the observable acceleration. With Oumuamua gone forever, we will never know for sure what its chemical composition was. Seligman hopes that new interstellar visitors will be discovered soon, which will help astronomers find any remaining answers and provide a window into other star systems in our Milky Way galaxy. New telescopes that are expected to supercharge this research are expected to come online within the next decade. But as scientists were still debating on what Oumuamua was, they discovered something else. Oumuamua was not alone. What has been accompanying this interstellar object? Could that be another situation to worry about? What role does it play in Oumuamua's arrival on Earth? Let's dive further to get adequate answers to the questions. Chapter 5, 2I Borisov. In 2019, Gennady Borisov, an amateur astronomer at the Margot Observatory in Crimea, spotted a new comet named 2I Borisov. You already know where the name came from. 2I Borisov was racing through the space at an astonishing speed of 93,000 miles per hour. That's 150,000 kilometers faster than what you would expect for an object at such distance from the Sun. Apart from its speed, its trajectory attracted scientists' attention. It was in an orbit with a very high eccentricity of 3.7 when it plunged into the inner solar system at a 40-degree inclination to the ecliptic plane. This suggested that Borisov had a separate extrasolar origin, just like Oumuamua. Borisov was clearly identified as a comet by its distinct tail. Its trajectory was toward the Sun, and on December 28, 2019, it reached its closest point, about 2 AU from Earth. It would brighten before dimming and possibly reaching magnitude 15 by its closest pass to Earth on December 28th. Experts may keep tabs on Borisov through October 2020 after it has faded for amateur watchers. In October 2019, Dr. Meach's team observed Borisov and assessed its size between 1.2 and 10 mil. They also saw that CN gas was being emitted from the comet's surface, but due to the comet's faintness, they could not detect other gases. However, the extensive year of observation made possible by the 2I's trajectory presented a singular chance to investigate its chemistry. This in-depth investigation will highlight two traits. The first is its unique comet-like look, which gives it a reddish color and is more in line with our conventional notion of solar system comets. This divergence highlights the diversity of interstellar objects. Such distinctions are crucial for astronomers trying to comprehend the processes of forming other solar systems. This continuing investigation broadens our understanding of the larger universe, regardless of how it differs or is similar to our own. In the meantime, some astronomers have dared to speculate that Oumuamua might have extraterrestrial origins. To further pique interest, a Harvard scientist article and the head of the Pentagon's UFO office have suggested that there may be an extraterrestrial mothership in our solar system that sends tiny probes, similar to dandelion seeds, to explore the planets. The Department of Defense formed the Pentagon's All-Domain Anomaly Resolution Office in July 2022 to identify and research interesting objects. The office's director, Shan M. Kirkpatrick, announced this. However, after the 2I Borisov, another object was also discovered in space. What could this be? And could it mean that the Earth should be expecting more than just Oumuamua in 2 weeks' time? Chapter 6. Meteor. 6 months prior to Oumuamua's near encounter with Earth, a tiny interstellar meteor with a diameter of around 3T collided with our planet. Despite having nothing to do with Oumuamua, Avi Loeb was intrigued by the meteor known as M2. He thought an artificial interest object could act as a parent craft, releasing multiple tiny probes as it passed close to Earth, similar to NASA's spacecraft missions. In their draft study, Kirkpatrick and Loeb delve into unidentified anomalous phenomena, the government's preferred term for UFOs, while adhering to accepted physics. They speculated that the craft's propulsion or the sun's tidal gravitational force could separate the dandelion seeds from their parent vessel. The scientists postulated that because of their small size, which would limit their ability to reflect sunlight, the dandelion seed probes may travel to Earth for examination without being noticed by survey telescopes. In line with their concept, these probes' technology may allow them to slow down in Earth's atmosphere in order to avoid burning up, and then they may use their parachutist-like characteristics to land. According to scientific theories, extraterrestrial societies may be interested in learning more about our solar system's rocky planets with atmospheres. Planets such as Mars, Venus, and Earth would pique their curiosity. The intelligent extraterrestrial society that made the probes wouldn't necessarily need to reside on the mothership after finding evidence of liquid water. It's also unlikely that the mothership will be able to communicate with these probes. It's an interesting idea that a planet that could support intelligent life could have sent out probes long before Earth did. Loeb likens it to periodically checking our mailbox, even if the senders are no longer in existence, for accumulating packages. Since he first suggested that Oumuamua might be an alien spacecraft, Loeb has encountered resistance from the scientific community. Some consider his theory that Oumuamua was purposefully sent to Earth provocative and unfounded. In 2021, a letter denying the possibility of interstellar travel was published in the journal Astronomy and Astrophysics. The letter cited the cosmic timescales needed to travel between stars. The authors concluded that it is more plausible that an oddly shaped rock that strayed into our solar system caused the Oumuamua than an alien civilization sending it. Another analysis has successfully refuted the theory that Oumuamua's mysterious movements could have been caused by an alien spacecraft. Instead, it offers a tenable explanation that points to hydrogen off-gassing, which happened on March 22, 2023, as the most likely reason for the unusual behavior. Nonetheless, the Pentagon has recently redoubled its efforts to look into enigmatic aviation occurrences within U.S. airspace. Since its beginning, the All-Domain Anomaly Resolution Office has opened over 360 new investigations into U.S. military personnel's claimed experiences with unexplained aerial phenomena. About half of these incidents have been linked to balloons or related objects, while the other half don't have enough information to draw firm conclusions. In the quest for knowledge, people like Elon Musk believe advanced telescopic scanning may reveal more alien objects. These findings can benefit researchers by providing opportunities to test their hypotheses. The similarities to the discovery of planets provide a positive example of these initiatives. The first exoplanets outside of our solar system were found just 20 years ago, and in that time, our knowledge has grown significantly, establishing the existence of over 4,500 exoplanets. This trajectory highlights the quick advancements in the field of astronomical research. Then, scientists began to debate the possibility of reaching Oumuamua and the possibility of the object arriving on Earth. This led to the wormhole concept. Chapter 7. Wormholes. Humans must better understand dark energy in the universe in order to build spacecraft that can explore Oumuamua. Sending a craft after the asteroid probe is one idea, but it will be extremely difficult. Oumuamua will pass beyond Saturn's orbit in 2 years because of its hyperbolic excess velocity of 5.5 AU per year. This isn't like the fastest item that mankind has ever launched into space. What kind of vessel can then take up such a task? And should we employ solar sails or something more unusual like wormholes for propulsion? First and foremost, we have a plethora of creatures that live and have lived on this planet, of which 99% is long dead, and none of what was here or is here now has ever cared about life outside of its own circle. Of course, birds, reptiles, and fish don't care about space except for humans. If that's the case here, who knows whether creatures outside of Earth may have the same mindset? Take whales as an example. They are intellectual species, but it is clear that they care less about space. It will be absurd to think they will want to communicate with humans or extraterrestrials. Given the roughly 14 billion year age of the ever-expanding universe, and the fact that we have only had a little more than a century of the sort of technology that could even begin to hope to detect alien signals, we are unlikely to find them in our lifetimes unless they use electronics and radio waves. Considering how vast the cosmos is, all of the sounds, waves, signals, and stuff we've launched into space, it's like staying at the foot of a mountain and throwing a grain of sand up toward the peak in the hopes that it would touch a bird perched on the pinnacle. That's exactly the delusion scientists appear to be under despite the acclaimed observations of aliens' presence. To solve this conundrum, they devised the Fermi paradox, hoping they were correct. The Fermi paradox is the apparent conflict between the fact that humans have found no evidence of intelligent extraterrestrial life despite the probability that it exists, given what we know about the universe. The word paradox means a statement that contains conflicting ideas. In this case, it would be something like, extraterrestrials likely exist and travel through space, but we have not seen them. The probability of intelligent extraterrestrial civilizations is based on the knowledge that there are 400 billion stars in our galaxy, many of which are likely to have planets with conditions that support life as we know it. Because many stars are billions of years older than our solar system, it seems probable that intelligent life would have developed on some of these planets and that those civilizations would have been advanced enough to develop technology for interstellar travel. And yet, at least according to conventional sources of information, we have found no evidence of extraterrestrial civilizations. A corollary to the Fermi paradox is that since efforts to detect intelligent extraterrestrial civilizations have been futile, we should not devote further resources to this search. Critics of the search have proposed reducing funding for such efforts because they believe aliens are non-existent until they appear. The Fermi paradox is named after a scientist named Enrico Fermi. The idea arose from Fermi's remark during a discussion with other scientists over a New Yorker cartoon depicting aliens landing in New York City. "Where is everyone?" Fermi reportedly inquired. His remark has been misinterpreted as, "If extraterrestrials exist, why aren't they here?" This is a big question to which no one has yet found a suitable response. While we can now make better estimates of quantities such as the number of stars in each galaxy, the number of galaxies in the universe, the fraction of stars that are similar to our Sun, and the fraction of Sun-like stars with potentially habitable, Earth-sized planets, there are still a few enormous unknowns out there. Although we can confidently assert that we fully understand or have the answer to probabilities, such as the possibility of creating life on an Earth-like world, and the likelihood of that life evolving into an intelligent, communicative, and possibly intergalactic species, we have no clue how likely or unlikely these events are in terms of raw probability. Sure, there are plenty of great achievements scientists and astrologers are making. We can talk about the experiments we've done to create organic molecules from raw, inorganic ingredients. We can discuss the complex organic molecules in interstellar space or meteorites. We can mention the tantalizing hints that worlds in our solar system house about watery pasts, subsurface liquid oceans, and potentially fossilized microbes. We can look at the fact that if we extrapolate the genetic information encoded in extant organisms back to the formation of the Earth, they indicate that what we consider life may have originated billions of years before the birth of our planet. However, none of these is appropriate for assessing the odds of life originating from non-life in an Earth-like environment. Some have estimated that the chances are quite high as a few percent. However, the probabilities could be disastrously low, 1 in a million or worse. Life can be extremely rare. The presence of life on Earth does not imply that it will exist on other worlds. A sample size of one cannot allow us to draw a valid conclusion. And potentially fossilized the genetic information there's no point in making conclusions from a position of insufficient evidence, and things get even worse when we try to term them intelligent aliens. Another uncertain conclusion. What gives us the assurance that they are intelligent, sentient, spacefaring, and communicative across interstellar distances? No amount of fancy probabilistic analysis can justify treating guesswork and wishful thinking as having any sort of scientific weight. Applying scientific techniques to an inherently unscientific endeavor, such as inventing estimates of unknowns about the universe, doesn't make it any more scientific but an illusion. It's still possible that life, and even intelligent life, is ubiquitous in our galaxy and the universe. It's also possible that one is common and one is uncommon, or that both are extraordinarily rare. Until we have more information, then the Fermi paradox remains null. This is to show that proper treatment of scientific uncertainties dissolves the Fermi paradox by showing that it is not at all unlikely for us to be alone in the Milky Way or the observable universe. Fermi's paradox is the dissonance between the high probability of the existence of extraterrestrials and the lack of evidence pointing toward their existence. There are many innocuous solutions to the paradox: lack of technology to communicate or travel, intelligent civilizations being too far apart, etc. However, the dark forest theory is a truly terrifying explanation for the paradox. The most interesting fact is that we don't even know how alien life would think. Like the dark forest theory, they may prefer to be silent. All these theories are based on how humans think of things around us, but alien brains could work completely differently, making their thoughts and strategies impossible to predict. They may choose to keep themselves as hidden or visible as they so desire. Better still, let's consider another line of thought. The thing with the Fermi paradox and other ventures such as SETI assume that they are older, more advanced civilizations than us that have surpassed our technology level. What if that's not the case? What if we are the most technologically advanced civilization in the galaxy? What if they haven't reached the level where they're capable of sending transmissions? Then, our current methods of searching for them would yield false negatives. Radio is only a little above 125 years old. Suppose the next most technologically advanced is only a century behind us. In that case, they've only been transmitting for a decade, and the signals haven't existed long enough to reach us yet. If we're 2 centuries ahead, it roughly puts them at the Napoleonic era. Thinking we are alone in this universe is absolutely insane, and there is no way we can possibly prove that we are alone either. Imagine they are of a civilization so advanced that they are watching us in the same way we watch TV, just for their entertainment. Another possibility is that alien life may be so alien that the ideas of exploration and conquest never occur. There are so many hypotheses and probabilities, leaving us with many unanswered questions. Is the dark forest theory sufficient to explain all of our questions? Is there a parallel universe? What are the origins of black holes? And so many more questions. Chapter 7. Black holes. Talking about black holes, astronomers just detected a massive black hole close to Earth. Scientists recently found a massive black hole close to Earth, and upon close observation, astronomers discovered something strange and unusual happening around it. NASA scientists claim this discovery might completely alter our understanding of how the cosmos functions. Could this discovery pose a threat to our planet? Also, what mysteries surrounding black holes have scientists been keeping from the public? No other cosmic phenomenon is quite as fascinating as black holes. In black holes, gravity is so strong that not even light can escape their pull. They are believed to form from collapsed stars. There are black holes scattered across the universe, with over 100 million thought to exist in our Milky Way alone. Several science fiction thrillers have featured them, notably the 2014 film Interstellar, and they are frequently portrayed as terrible monsters who engulf everything around them. Ironically, we often believe black holes are out there and far away, but it was not until a recent discovery that this narration changed. Black holes are real and closer to us than ever imagined. A team of astronomers recently announced they found a black hole about 1,600 light-years from Earth. A light-year is the distance at which light travels in 1 year. In space, light travels 9.4 trillion kilometers each year. The team discovered it using the European Space Agency's ESA Gaia spacecraft while observing the motion of its orbiting star. They named the black hole Gaia BH1 since it sits amidst the collections of stars in the constellation of Ophiuchus. The team estimates the black hole to be about 10 times the mass of our Sun and 3 times closer to Earth than the previously found black hole. Thus far, the Gaia spacecraft has detected more than 800,000 multi-star systems, so no one can deny its credibility. However,